Hello everyone, we are the student of Guwahati University and we have prepared a project on fire monitoring, detection and live location reporting using a set of program, optical sensors, web service and artificial intelligence. So, as we know, fire is an essential source for our livelihood, but it can also be really hazardous. It can cause destruction in a few seconds. It can cause damage to properties and affecting not only human lives, but also animals, basically affecting the flora and fauna of the ecosystem. So, an all-in-one solution is needed to solve this issue. Hence, we have made a model which is portable and also cost effective, as you can see here. So in the first phase of our project, we have made a forest fire detection and monitoring system. And in the second phase, we have made a portable fire monitoring and detection system with live location to be sent to the user using our module and a provision to alert the nearest fire department. An alert system is also included along with the module to alert people nearby. What we did in the first phase was we have used computer vision to do the detection. We did not have any hardware model as such, and what we did in the phase 2 is we have implemented it in a hardware module as well so that it can be portable and it can be used anywhere. The technologies we have used are YOLO V5, which is a machine learning algorithm for training the dataset. We have also used Google Weather APIs for live weather updates. The parameters which we have used are temperature, humidity, pressure, and also weather. Google Maps are used for live location, and we have used Twilio SMS API for alerting or notifying. The components we have used are ESP32 CAM Wi-Fi module, which is our actual module for where the camera is there. We have also used Arduino microcontroller for uploading the program and an FTDI 232 mini. This is a USB to TTL converter which allows us to operate at 5-volt supply, and we have also used the server. So in this block diagram, we basically uh, gave ground truth data, which is our label dataset. This dataset is trained in the YOLO V5 network in which the labeled images are tested to identify the fire. Then it is deployed and implemented in the Arduino board.
So we have used YOLO V5 for training and testing, which is basically a small weight of YOLO V5. YOLO has convolutional neural network where there are operations like convolution, pooling, then there is an activation function called relu. The mathematical part here shows how feature detection is done, where functions like kernel and stripe detects the features required in that particular image, which in our case is fire. Padding is done so that extra important information isn't missed out from a matrix. There are two types of pooling: operations, which gives the maximum detection feature. We have used the maximum pooling. In labeling part, the first image shows how we have labeled the images before training, since our dataset wasn't previously labeled. The next image shows how YOLO has predicted those labeling image boxes. So in some image its prediction is fine, but there are no prediction in a few.
So this is basically what we have done in phase one. In phase one, we did only computer vision and deep learning part. We use YOLO V5, the S model, small model, and we use webcam as our optical sensor. And we gave the feedback to monitor and used our web server as monitoring station. And we also did thresholding where we took our threshold value as 0.44. Uh, so briefly, if I explain it, it's like we took a fire video which was extracted into the frame, and the frame dataset has two parts here is training image and the testing image. Training image is also contains labeling images, and YOLO V5S, which we have used in our model, has two parts: that network code and the weight pre-trained code, which has further went to the training model, and the model has been predicted with the testing model, and then fire has been extracted. This is the observation of the dataset one. Here we have used two datasets. So dataset one result we have precision we have got 0.6 and recall of 0.4, which was trained with 1155 images, where 337 base images and rest was augmented. We did augmentation to increase the number of images to get more precision and recall. And this is the result of the dataset 2, where we have got a slightly greater precision and recall of 0.7 and 0.6 respectively, which we have trained on about 1200 approx images, where 800 base images was taken as augmented.
So in work done in phase 2, this time we have considered a larger and a much better label dataset. We use the YOLO V5 again. A website is created. We used ESP32 CAM Wi-Fi module, which acts as a microcontroller. We have used Twilio SMS API for alerting or notifying nearby fire departments. From the flowchart, as we can see, we are first given some video feed which is received by the ESP32 cam, and the fire is detected using a threshold value of 0.44 in our case. It can be adjusted. Then if the fire is detected, result is rendered. This result is then sent to front end, which is our web server. We wanted multiple input, multiple output, so that is useful for n numbers of people. So we have used 2000 approximate images in our new dataset, 987 base images and 1100 augmented images. This is the precision recall curve and the hyperparameters. These are the hardware and software configuration of the experimental setup, the GPU and CPU and the environment where we train this model. This is the video. So here we have the login page of the server. We give a password and a username, which is admin by default for now. This is the station A. I'm skipping it. This is the station B. So this is how the fire is detected and the location is also revealed. Similarly, in station B, the fire is detected in this way. This is how the alerting message is shown using the Twilio in our mobile phone, the registered number. In conclusion, we have found that YOLO is a lightweight algorithm. YOLO gives us a better FPS compared to other algorithms like inception, solving our problem of latency and accuracy in the device used. We are processing different feeds using the concept of multi-threading. ESP32 CAM module is used here to resolve the problem of portability and mobility, portable fire detection, and tracing module with an alarm system which can be used in any indoor or outdoor places. The limitation which we have faced is that there is low accuracy of the train model. YOLO V5 is not able to give a better accuracy like a faster RCNN. Low dataset size, lack of better legal dataset could not acquire precise location using GPS. For future directions, implementation with advanced AI and embedded systems for more precise fire detection and monitoring, expanding the horizons of API, connecting the users to this system, making it a valuable product to prevent fire hazards, training the model on a larger and a better level dataset to get better accuracy. Thank you.